Good morning, good evening, greetings to everyone. Thank you all for attending today's webinar. And the topic which we have for you today is automating your hardware test lab in the time of COVID-19. Before we go into the presentation, let me go over a few housekeeping rules. Today's webinar is being recorded, and we will email to you the link to the recorded webinar tomorrow. Feel free to share this with your colleagues as well. In case you have any questions, you could submit these into the questions tab, which you could see on the right side. We will be answering your questions during the webinar and also towards the end of the webinar. So with that, let me introduce the speaker for today, Krishna, who's our Senior Technical Marketing Engineer and who has worked with multiple of our customers in deployments for lab automation solution, will be going over the presentation and the demo. Alexandro Barberi, he's our VP of Product Management. And this is Jay Jogsy. Alexandro, myself, we both will be answering your questions which are put into the chat window. So with that, Krishna, passing on the ball to you.
Thank you so much, Jay. Hello, everyone, and good morning, good evening. Welcome to the presentation and the demo of the Pluribus Lab Automation Solution. Before we get started, let's quickly take a look at today's agenda. We'll start the presentation by taking a look at the challenges faced in the traditional labs and what are some of the existing solutions that are currently available in the market. Then we'll take a look at the Pluribus Lab Automation Solution and how do we address these challenges and add more value to manage and operate your labs. And finally, we'll check out a short demo of the Pluribus Virtual Wire Solution, making multiple DUT connections at the same time. And so let's get started with the challenges of traditional labs. As labs grow, we are running into challenges of managing these labs day to day, and agility is hampered by growth. The traditional way of operating and managing a lab becomes difficult once the lab starts to scale. The first and foremost challenge of any lab is the amount of manual work involved in making these connections between multiple DUTs or tools. As the need to make more connections increase, so are the chances of making errors connecting these connections manually. The scope to automating the test environments and sharing of resources becomes limited in a traditional lab as well. This is because of the manual aspect needed to make these connections that are involved. And most importantly, managing a lab remotely 24/7 is very limited, and more so in situations like that we are currently in. So in pandemic environments that we are currently facing, managing and operating a lab remotely becomes much more difficult. So we address these challenges that are faced in traditional labs using the Pluribus Virtual Wire Solution. And this solution also adds additional value in managing and operating a lab environment. So right off the bat, it removes the need of a lot of manual work needed in the labs. So all the DUTs or the tools or servers need to be connected to the virtual wires, and the DUTs can be interconnected to each other using the software, which would remove the chances and the times where the wrong connections are made, and it also greatly reduces the time taken to make these changes. And automating a test environment can be done from a layer 1 level, which increases the opportunity to share the resources between multiple teams or interconnecting multiple test beds with each other. And finally, it gives the users and lab administrators to almost completely manage the lab or DUTs remotely 24/7, with the only possible access probably needed to replace bad connections or cables or add new connections that might be needed. So any of us who have ever been in a lab to make a connection to the DUTs or basically have new DUTs racked up knows the nightmare of having to trace a cable or a connection between these two devices. Any lab starts off easy to manage, but quickly the lab manages to grow into something that's very hard to manage, difficult to debug, and this can be seen by the poor guy standing here trying to figure out what's going on with his network. And we are addressing these problems using the Pluribus virtual wire solution. So the lab instantly transforms into something which is much cleaner and easier to manage, as the only interact connections would be between the virtual wire switches, which can be managed using the software. So to put it in simple terms, all the layer 1 connections in the lab can be connected using a computer. So the virtual wire solution can be seen as a software patch panel for your lab. So what are the current and existing alternatives or the current solutions for layer 1 lab automation solution? Overall, we have two different types of solutions, the photonic switches or the packet broker like solutions. So the packet, and though these actually have a lot of advantages, and they tend to give the users the ability to interconnect DUTs on a layer 1 level, they have their own limitations. The photonic switches do not interoperate between different transceiver types, and they are limited to a number of ports by the chassis. So the only number of devices that can be connected are the number of ports on the chassis. And if someone wants to interconnect copper or multimode fiber, they are typically not supported. And the packet broker like solution addresses some of these issues of the photonic switch, but still they fall short on many important features, like the lack of reconvergence in case of a link failure and the inability to load balance the traffic. And both these solutions cannot extend these connections across multiple labs, which is a huge disadvantage when a lab needs to be scaled or extended. So at this point, I'd like to introduce the Pluribus Layer 1 solution. So what do we do in the Pluribus Layer 1 solution? So we address the basic issues that are already present in the existing market, solution, while adding value in much more ways that the user and the lab administrator can take the leverage of. To start off, we use the standard open networking switches, which actually gives the users an option to select from multiple vendors, also reducing the cost to procure these switches. And one of the main advantage of the Pluribus virtual wire solution is it is completely speed agnostic as well as transceiver agnostic. So the connections can be made between any speeds from 100 meg to 100 gig, and the connections can also be made between multiple transceiver types from copper to fiber to multimode to single mode. So this gives the user a lot of options to connect their devices in a single solution. And most of the open networking switches that are currently in the market use controllers. But the Pluribus virtual wire solution addresses these issues by removing the need of a controller, which would actually reduce the cost further. And because of the distributed nature of the Pluribus NetWiser, which is baked into the operating system, the entire chassis is technically virtual in nature, which means any node of the fabric can be accessed, controlled, or managed using any other node of the fabric. So if I have 10 nodes that are sitting across two different labs, I can log into lab 1, node 1, but still look into node 9 that is sitting on lab 2. And uh, this is a very unique feature that's offered by the Pluribus virtual wire solution, which actually allows the users to share resources across geo-distributed labs. So what I mean here is basically two labs that are sitting across two different regions. The DUTs that are sitting across these in these two labs can talk to each other, which actually greatly improves the opportunity to share resources across multiple labs. And finally, and most importantly, we use open APIs. So if a customer wants to, they can automate using Ansible, Python, and we also support CLI and APIs. And the most important thing is we have a GUI called Unum, which I will go into a little bit going in the next slides, which would actually help the user make these connections much more easily. We also play well with third-party vendors like Quali, with whom we are fully integrated, where the user can make use of their existing Quali deployment, download and install the driver for the Pluribus virtual wire, and continue using their lab resources like previously. So let's quickly take a look at the physical topology required for the virtual wire solution. The user needs to connect all their traffic tools, test beds, devices, servers, and whatnot into the leaf switches that are running the Pluribus NetWiser operating system. And these leaf switches can be connected either to Pluribus, either to the Pluribus switches running NetWiser or white box switches, or any third-party spine that are currently deployed within their network, let it be Cisco, Arista, Juniper, whatever. So any of these existing spines, as long as they talk regular IP like BGP, VXLAN, so as long as they actually talk regular networking, these can be interconnected using the DUTs can be interconnected using the virtual wire solution. So though even in the case of the leaf switches connected to third-party spines, all the leaf switches running Pluribus NetWiser do run as the same fabric. So all the user has to do is, in case when they want to make a connection between a traffic generator and any other test bed that's connected to a different node, they have to just select the endpoints where the DUTs are connected, and the connection is automatically made. We'll look at it in detail during the next part of the demo, and all this can be controlled using Pluribus Unum, REST APIs, as well as mentioned in the previous slide, we play well with third-party softwares like Quali. Let's quickly take a detailed or an in-depth look of some of the features that Pluribus virtual wire solution presents to the customer. So the first one, as already mentioned, is we are completely transceiver agnostic. So a DUT that only supports a single mode fiber can be connected to a device that has multi-mode fiber connected to it. Or a 10 gig port can be connected using to a 100 gig port using the virtual wire. Or any legacy DUTs that are still running copper can be connected to the latest devices that are connected to the fiber. So in case I have a legacy device that still uses copper, but if I need to send traffic to it or connect a tool to it, but if the tool or the traffic generator only supports a fiber connection, the connection can still be made, and it is as though both the DUTs are directly connected to each other. And one of the other wonderful features of the virtual wire solution is the transparency to all the protocols, error frames, and Ethernet types. So if we actually see it with a lot of customers where they have a lot of testing going on, in the use cases where they want to send traffic that have CRC errors or they are runt packets, like a 50-byte packet or something like that. So the virtual wire is completely transparent. All the CRC error frames and runt packets are forwarded between are transported between the devices without any issues. So are the protocol packets. So if I have an OSPF packet, a BGP packet, an ISIS packet, all these are transparently sent across the virtual wire, and so are all the Ethernet packets like MPLS or FCOE and so on and so forth. So all the packets are completely are transparently forwarded across, even if they are connected across 2 geographic locations. And finally, I'd like to point out one of the wonderful features, which is link state tracking. So let's say if I connect 2 DUTs that are running 2 different port speeds or 2 different transceiver types to each other using the Pluribus virtual wire solution, and if one of the port is brought down administratively, or if the port actually goes down because of a cable issue or because the DUT went down, the link state is transparently transmitted across to the other side, which would ensure a complete and transparent end-to-end link connectivity. So even if, again, I'd like to repeat, so the same functionality works well, even if both the ports are connected across 2 different labs or 2 different geographic locations. And this feature can be enabled or disabled as per the user requirements, but it is enabled by default. Moving on. What are some of the unique features that the Pluribus virtual wire solution gives you as a user? So the first one is high availability, which are not present in any of the existing solutions. So what do I mean by high availability? So we basically, the hardware basically computes the best path automatically in case of an ECMP, or in case where I have multiple paths to choose from. The hardware picks the best path and the traffic is directed towards the best path. But here comes the beautiful part. In case if there is a link failure, we provide a sub-second failover to a new path, and this ensures that the traffic actually goes through without the need of any user intervention. And the user can create alerts if need be, which in Unum, which would actually help them understand that there was a link failure without having to wait till something goes wrong badly. We'll get to it during the demo part. And finally, we actually support per flow load balancing. What I mean by this is, if I have 100 flows that are coming in from a single port, all the 100 flows are not sent using the same uplink. They are actually distributed across all the available paths, which would mean that the link utilization is much more easy across the network, and there is the less chances of oversubscription because of multiple flows. And finally, Pluribus virtual wire uses the fundamentals of NetWiser that are baked into its operating system. And because of the distributed controllerless fabric architecture that the Pluribus NetWiser supports, we use the same fundamentals and apply it to virtual wire, which would give us a unique solution where the users can share devices or tools across multiple geo-distributed labs. So what I mean by this is, let's assume I have traffic generators or tools that are only available in my north and south labs. And if I want to make a connection between the traffic generator that I just selected and a DUT that I highlighted right now, the current options are either one, the lab in the west has to buy a new resource, or the tool or the traffic generator that's sitting in the lab at north has to be transported to the lab here and the connection has to be made. So we actually provide a unique solution where, as long as these two labs can talk to each other using basic IP or WAN, the devices that are connected to the virtual wire can transparently be connected between themselves. So what I mean is we still support all the features of virtual wire of a complete transparent link with link state tracking, error packet and protocol transparency, and all the features that we just talked about in the previous slides across multiple geo distributed labs. And one of the other beautiful features is, and we actually have this deployed in some of our customers, is because of the automation support that's built into the Pluribus NetVisor. If, say, for example, the tool has to be is used in two different time zones, let's say Australia and South Africa. So the tool can be automated to make sure, let's call this Australia, and just let's call this South Africa. So in the morning, the tool can automatically be scripted using, again, REST APIs, curl, Python, Ansible, and multiple other ways to make sure it actually connects to the Australia during their work hours. And once the South Africa teams comes in to work, the connection to the Australia team is disconnected and the new connection is automatically made. So this gives a lot of flexibility to share the resources, which would reduce the capex to the organization as well. And again, this entire the entire fabric spanning across multiple labs can be controlled and managed using a single Unum instance. And again, we are the only solution in the industry to support that. Let me take a couple of minutes quickly to introduce Unum. So Unum is the graphical user interface that's owned by Pluribus. So basically, what it does is it gives it actually does two things at the same time. So first, it gives the users an easier way to make connections between the end devices. So what I mean by that is all the user has to do is just select the end devices, and all the CLI commands are automatically done by the Unum. And the other advantage of Unum is it gives the user a graphical representation of all the connections and the status of each connection. So as you can see here, everything is color coded. So red is basically either the connections are down or there is something wrong with, or the ports are down. So basically the user or the administrator can take a look into it on what's happening. And green is okay. And we also have yellow, which means there are multiple connections between them, and some of them are active, some of them are down. So it gives the user a quick glance of what's happening. And it also gives the network or the fabric administrators or the lab administrators an overall view of what's happening within their network. I'll dig deep into this during a demo part so that it's much easier to understand. Moving on. So what does the Pluribus lab automation solution, what do we provide? So first of all, we actually provide remote management. So again, all the labs can be managed from anywhere in the world. As long as you have access to internet, you are good to go. And because most of the labs have VPN, so as long as you can connect to your VPN, you can manage your lab 24/7. So no issues. There's no need for someone to go to the lab physically and do it. And we are actually managing most part of our lab and traffic generators and tools the same way, which is helping us because of the lockdown in California right now. And the other advantage is it saves a lot of time, again, as I explained in a couple of slides back. So what we do is the user can automate their the resources, if they are time shared between multiple teams, so which would actually kick in right away. So the teams do not have to worry about setting up their test bed once they come to work every day in the morning. And we reduce costs and errors because most of the traditional labs have a human element that is needed in them, which would actually increase the cost and chances of errors of something happening within the lab. So these two are minimized. And finally, we increase the capacity and utilization we increase the capacity of the lab because the lab at this point can be scaled on demand. So if I have 2 racks currently, and if I need one more rack to install in a lab, so this can be done even in a remote lab because all the devices can talk to each other. So the lab administrator or the network administrator does not have to worry about probably like 2 years into the future on what might be the scale of the lab at that point. And finally, the resource utilization is increased because we allow the sharing of resources from a layer 1 level, which would actually reduce the cost as well. And that being said, we'll quickly dive into the demo. Before we move into the demo, let's quickly take a look at the topology and the agenda for the demo today. So the topology, what we have is a simple triangle, a spine leaf architecture. So we have 2 pluribus virtual wire switches that are acting as leaf switches currently. And these 2 switches are connected using a spine. And each of these leaf switches has an Ixia that is hanging off of them. And as you can see here, one of them is a 40 gig port and the other one is a 10 gig port. And we have 2 Cisco switches, 2 Nexus 9Ks that are hanging off of, again, each of these leaf switches. And for today's demo, we are going to send traffic between the Ixia ports, again, that are running 2 different port speeds. And also the 40 gig is a fiber and the 10 gig is a copper. It's an RJ45 connection. So we are actually going to make a connection between these 2 traffic generators that have different speeds as well as different transceivers connected to them. And we are going to send traffic between them. So we'll send TCP streams, UDP streams, jumbo frames, and bad CRC packets. And then we are going to make a connection between the 2 Cisco switches using and make sure the OSPF that's configured between these 2 switches can talk to each other. Again, that being said, let's get started by making a connection between the Ixia ports. So before we move on to making a connection between the Ixia, before we move on to make the connection, let's quickly send the traffic between these 2 devices. And again, as you can see, one is a 40 gig and the other one is a 10 gig connection. So let's quickly start the traffic. And because as of now, we don't have a connection between these 2 Ixia ports or the traffic generator ports, no traffic is received on the other side. So we'll let this run, we'll make the connection, and then we'll make sure that the traffic is received after that. Before we do that, let's quickly take a look at Onum. As you can see here, the Onum default view is it gives the user a view of what the topology is. As you can see, we have a third-party spine that's connected to both the pluribus switches, and then we have both the Cisco switches that are hanging off of the pluribus leaves. And we don't see Ixia as of now because we depend on LLDP to discover what's connected on the other side. But that being said, let's quickly make the connection first. So making the connection is very easy. All the user has to do is just select the endpoints. It would bring up the portal. The user just gives it a name. I'm going to say call this Ixia01. And I don't really have to know what ports the DUTs are connected to. all I have to do at this point is, because I can just type the name, and all the DUTs are actually, all the ports of the leaf switches can be named by the DUTs that they are connected to. So once I type the name, it actually brings up saying to IXIA port 24, which is the name I have given to the port, and do the same on the second port as well, and just say submit. So as you can see, it says the connection has been created successfully. It's discovering the connection, and the connection is a green. So now once we go back to the traffic generator, we see that the traffic is being received on the other side. And we see a lot of discrepancy between the bytes sent and the bytes received, because the traffic was not received for a long time. The connection was not made for a long time. So let's stop this right now, clear the statistics, and let's take one thing at a time. So basically, let's start by sending the TCP and the UDP streams. And okay, now let's go back, start the traffic. And again, we are sending at, yeah. So again, as you can see, we have sent, let me stop the traffic. Again, as you can see, we have sent approximately, how much is it? 9 billion frames from the 40 gig link, and all the 9 billion frames have been received on the 10 gig, and we have sent close to 5 billion from the 10 gig link, and all the 5 billion have been received on the other side. And exactly, it matches to the dot. So we do not add any overhead, and all the packets again are transparently transmitted across. So now quickly, let's take a look at the jumbo and CRC frames. So as you can see here, we are sending packets with 9,000 bytes. So so this demo is just to make show that even a packet with a bad CRC can be transparently transmitted without any hiccups or issues. So which is one of the most unique differentiators of the virtual wire solution. So as you can see here, we are sending around 4 billion as of now, and 5 billion have received, and same is the case here. And if you look at this, the traffic generator reports CRC errors because we are sending CRC error packets. And it's also reporting oversized packets because we are sending jumbo frames. And that being said, we'll just start all the traffic at once. And we are actually going to cause an oversubscription because we are sending 20 gigs of traffic from the 40 gig link onto a 10 gig. So this is going to cause an oversubscription and congestion in this. So let's take a look at it in a few minutes. Again, so the reason I'm causing an oversubscription is to show one of the other advantages of Unum. So in case if the user wants to see what's happening from within their connection, so all they have to do is just click on the link. It is actually going to show all the statistics of whatever is happening within their connection from right there. So it basically says that leaf 1, we are sending over 10 gig of traffic. So there is a congestion that's actually happening on leaf 2 because this is a 10 gig link. And because we are also sending packets with bad CRC packets. So these packets are actually, I apologize for that. Let me just go back. Sorry about that. So these packets are actually reported as errors. So the user has the option to see what's happening with their connection in real time. And before we move on, let's quickly take a look at some of the features that are available for the network administrators or the lab administrators in Unum. So again, as I said, one of the features is it actually gives the user an overall view of what their network is. So if one of their nodes is down, it actually shows that the node is not seen from the fabric. And it also gives the user a quick glance of what the health of each of their nodes is. So basically, as you can see here, it gives me my management IP, what is the state, is it online or offline, what is the CPU and memory utilization from within my switch. So it gives me a quick glance of the health of my fabric, while also giving me a quick glance of the health of the entire network. What I mean by that is, as you can see here, we have the memory utilization, CPU utilization, and are there any alarms within my network? And all the alarms can be seen here, and it gives me a quick glance of my fabric resources. But this is the main part I wanted to spend a minute talking about. It gives the user or the lab administrator a quick glance of what's happening within their network. So in case if there is a bandwidth utilization that's going over on certain links, that can actually be monitored from right here. So the user or the lab administrator doesn't have to wait till something goes wrong to see what happened. So the issues can be preemptively detected using the virtual wire, using the UNUM, and we can see that, okay, leave 2 input port is almost at 90% utilization of basically the input and output of leave 2 port 57 is almost at 90% utilization. And they can look at any potential issues like any errors or congestion drops. Like what we see here on leaf 2, it basically says that on port 49 there are error packets because we are sending CRC packets. So it gives us an overall view of what's happening within our network. And we see congestion drops on the output, like on the egress side of leaf 2 on port 57, which can be seen here. So this gives the lab administrators and network administrators an easier way to manage their network. And that being said, let's quickly go back, make a second connection. So the second connection that we are going to make is between the Cisco switches. So we have switch 28 and switch 27, which are again Nexus 9 case, and they have OSPF configured on them. So before we make the connection, let's quickly take a look at the current state of these two devices. Sorry about that. All right, I'm in. So now let's check by looking at the current OSPF configuration. And both of them basically don't see any OSPF neighbors. And if I try to check for LLDP neighbors, all right, so the LLDP neighborship, basically the OSPF neighborship is not established, but these two, because we are doing it on virtual wire, these two are already, oh yeah, this is 130. So we do not see any LLDP neighborship on port 124. So port 124 is connected on each switch. So we do not see any neighborship on port 124, as you can see here. So now let's make a connection between both the switches. So all I have to do at that point is make the connection. Let's call it Nexus 9K01. And again, I don't have to know what port it is connected to. If I know my DUT, I can just connect it using DUT and say submit. And it's created successfully. It's up. And the representation immediately changes to 2. So it means we have 2 connections between these 2 devices right now. Now, let's start by looking at the OSPF neighborship on both sides. As you can see here, once the connection is made, even the OSPF protocol packets are transparently transmitted across. And we see that on port 124, port 27 has established an OSPF neighborship with port 28 and vice versa. Now let's look at the LLDP neighborship. And again, as you can see here, now we have neighborship established on ETH 124. And same is the case here. As you can see, we have neighborship established on ETH 124. So now we are, since we are on the switches already, let's take a look at the link state tracking functionality. So we know that port 124 of each switch thinks it's directly connected to the other Nexus switch. So now let's do. We see that port 124 is up on both the sides. So we have port 124 up on both sides. So what we are going to do now is we are just going to bring down one of the ports administratively. So I go to the port and I just do a shutdown. All right, so once I do that, the link on the other side goes down instantaneously. As you can see here, the link goes down. And while we are here, let's quickly go back to Unum. And I'm just triggering it because I have configured this thing to wait for 30 seconds, but yeah, there you go. As you can see, it has turned from green to yellow. This means some of the connections between these two devices are currently down. So if I click this, it would actually give me more information on what ports are connected, and it gives me a visual representation of which port is down. And same can be seen here from under the details. So this gives the user a very quick view of what's happening. So now let's bring up the port. And as you can see here, the link came up right away. And the OSPF neighborship is established back as well. So it's the neighborship re-established. So the link state tracking really helps in the cases where I have multiple devices connected like these, which are running protocols or traffic. And there has to be a mechanism where the state of each of the port has to be faithfully reproduced on the other side. So this would actually help me a lot. And moving on, I'd like to just point out one more wonderful feature of Unum before we move on. So Unum actually gives me as a user an option to configure alerts. So we have just seen that one of the ports, the 10 gig port on leaf 2, which is receiving traffic from a 40 gig port, there is congestion and there have been drops. So imagine this being an uplink, or imagine this being the case where I'm using a testbed where there have to be no drops or the port shouldn't go down. So Unum gives me an option to configure multiple alerts. Let it be for error packets, in case of ports going down, in case of any congestion on the packet, or in case where the CPU or the memory of my devices are exceeding a limit. And again, these work with the pluribus switches only. You can configure alerts on the pluribus switches only. So the ports that are connected can be configured to make sure that the alert is received. So basically, it can send an email out to an alias of administrators, so they can actually take a look at a potential issue that might cause a headache in the future before it actually becomes a big issue at that point. So you can actually nip it in the bud, where you can see all the where you can configure the alerts that are needed, and all these alerts can be seen or can be seen using email, like they can be received in your emails. So one other last thing that I wanted to point out, so you can actually configure multiple connections at the same time. So let's say I want to connect test 01, and let's say this is for port 5 on between leaf 2 and leaf 1. And if I want to make one more connection, so I don't have to go back again. All I have to do is just say leaf test 2. And if this one I want it to be between two ports of leaf 1, I say between port 4 and port 6. Say submit. So I can I can make multiple connections at the same time. So both the connections are created successfully. And again, this is red because we only have one connection and we don't have anything connected to it. So as you can see, all these can be managed very easily, and this would actually give the network administrators and the lab administrators and even the end users and an easier way of what's happening within their network. And finally, so again, I just wanted to reiterate that the Pluribus Virtual Wire solution gives the network administrators and the user and the end users a lot of flexibility in making the connections while reducing the cost of the resources, the cost to procure more additional resources, while increasing the network or the resource utilization. And this solution has already been deployed across multiple organizations of service providers. We have universities which are using this. We have healthcare providers where they have the virtual wire solution that's deployed in their lab, energy sector, system integrators. So this can be deployed and across multiple verticals and makes the life of the end user as well as the lab administrator much more easy while reducing the capex for the organization. I'd like to thank you for joining in the session today, and we'd like to basically take any questions at this point. Thank you so much.
Thanks, Krishna. That was a great presentation and a demo. There are a bunch of questions coming up. I don't know if we'll have time for answering all these questions, but we will come back to you guys in case if we are not able to get to your questions, guys. We will reach out to you directly. So Krishna, just quickly going through a few questions. You talked about the management tool for lab automation. That's Pluribus Unum.
Yes.
The question coming is, can this management software run as a virtual machine, as a VM?
That's a great question. Yes, it can be run as a VM. So we have more resources available in the Pluribus website. So just to give you a quick answer, so the Unum can be run on a bare metal server, as well as the OVF can be deployed on an ESXi server, and it can be run as a VM. Yes.
Got it. Thank you. You talked about the software, the lab automation software, virtual wire running on switches. What switches are supported?
Sure. We currently support, on a broad view, we currently support 3 different types of white box switches. So the first one is we support Dell. So any Dell switch that can run NetWiser on top of it can be used for virtual wire. And same is the case with EdgeCore. So any EdgeCore switches that can run the NOS, NetWiser NOS do support it. As well as we have Pluribus's own Freedom Series switches. And all these switches can be used for the users to choose from. And we do support the ports, all the switches that support port speed from 100 meg to 100 gig.
Thanks, Krishna. There is one more which we'll be able to get to. Is there a limit on the number of connections between the switches?
A great question, actually. So unlike the traditional deployments, we do not cap the number of connections. We do not limit the number of connections. So as long as the bandwidth uplink is taken care of, the user can actually have as many connections as they need.
Thank you. So Krishna, that's pretty much we have time for. And folks, we'll come back to you in case we have not been able to get to your question. We'll reach out to you with the answer. But Krishna, thank you so much for your time and the demo and the presentation on lab automation and how it can be relevant in current situations, especially when many of us are stuck at home because of COVID-19. Thank you so much for your time. And audience, thank you for joining us. We appreciate this, and we will be sending the recording to you as well via email. Thank you.
Thank you, everyone.